everybody. Video number 6. We're getting close to being done. Today we're going to look at electrochemical cells, and we're going to spend most of our time in this video with voltaic. The last video is real quick, and it'll be electrolytic, okay? So electrochemical cells is the generic umbrella term. We're going to focus on two kinds, voltaic and electrolytic. Oops. We need the parts, and the flow of electrons through the electrochemical cell is the second one. And here is a perfect picture diagram of what's going on. Notice a voltaic cell has a voltmeter. There's a big thing. So voltaic is the main one we use. This is the spontaneous reaction that turns stored chemical energy into electrical energy, where just the electrons within the solutions in the metal can light the light bulb all by themselves. There is some stored energy in there that we can release. Electrolytic is the non-spontaneous reaction that needs electricity to make it go. Electrolytic needs electricity. We'll focus on those specifically next video. Electrodes. This is the metal that connects the solution to the cell. And you'll see in the picture there's a magnesium solid electrode and a copper solid electrode. And the metal you choose has a lot to do with the solution that has to be in there. Okay, so you have to match up the metal in the solution. Okay, the solution is going to have an ion of the same metal. Okay. Anode is the positive electrode, and this is where oxidation takes place. Angry ox, A-N-O-X, angry ox. Anode is where oxidation takes place. The cathode is the negative electrode where reduction takes place. You might want to take note of that positive and negative. That's going to help us understand some things that are going on. Okay. Direction of ion electron flow, always A before C. So always from anode to cathode. Electrons go from A to C. Another kind of letter game that we're going to introduce this unit to make sure we know which is which. So we have your choice of oil rig or Leo says Gur. We have angry ox, and we have A before C. So like I said, this is going to be like an acronym heavy unit just to make sure we help keep things straight. Okay, and then the salt bridge specifically, and this is asked every year just about, though in some way or another they want to know what the salt bridge is for. And all you really need to be able to say is that it allows ions to flow, and it also does complete the circuit. Allowing ions to flow is the most important thing, because when you see during the animation of the lab, when things are leaving the electrode and entering solution, the solution is going to become saturated and needs to have a way to get rid of some of the ions, and the ions flow in both directions to like kind of cancel each other out, and eventually the solution is going to be replaced. Okay. Now we are going to actually use two things in one. I'm going to take this balanced chemical equation at the bottom of that picture, and I'm going to put it in there. And then I'm going to be able to identify the oxidation and reduction going on, which is from our previous learning in video 4. So we're just going to combine the two things now. Ready? So I'm going to bring that Mg solid up. Here it comes. And I'm going to put the 0 on right away because I know it's by itself. I got a Cu with a +2. The charge is already there for me. +2. I have an Mg with a +2, and I have a Cu with a 0. Now, the nice thing about these particular reactions, when you see them like this, is a lot of times they don't have the spectator ion to kind of be a nuisance for you. Okay, so I'm going to have to figure out now. I like to do which one is the reduction first. So I have Mg going to 0, from 0 to +2. Is that going down, or is Cu +2 going to 0 going down? The Cu +2 going to 0 is reducing. So I'm going to go ahead and label that one first, because that one's the one that's easiest for me to pick out. So I'm going to pick out the Cu2. I know it goes to Cu0, so notice I put the reactant on the reactant side, the product piece on the product side, and then to go from +2 to 0, I must have added 2 electrons. Good? The oxidizing agent in this case would be Cu +2, number of electrons involved 2, and we're labeled up good. And now I know by default then, if Cu +2 was part of the reduction, now it's easier to get my oxidation reaction, which is increasing, but there's no way it says increasing on oxidation. Reduction at least helps me understand reduces to make smaller, so I can identify that one easier. Okay, now I can do oxidation by default. Reactant side, Mg0 goes to Mg +2, must have 2 electrons. The reducing agent now is Mg0. Number of electrons involved is 2. They pair up nicely. 2 electrons given off, 2 electrons taken up. We're good. And this is how we combine half reactions into an actual electrolytic chemical cell, the voltaic cell, if you will. The simulation on this piece gets really good at showing you what's going on at the molecular level on the electrodes. We'll talk about it more in depth in class to follow up with what you're going to see in the simulation of the lab. Just pay careful attention to the ions flow and why, and then the electrons go here, making an ion into solution, and the metal, one metal is going to get smaller, and one metal is going to get bigger. That's how it works. And with that, I think we might be done. It's basically that. This is just another picture of what's going on with that voltaic cell. I can give you a quick rundown because we got just a second. What's going to end up happening is this Mg metal here is going to release electrons and become Mg plus 2. So as he forms ions, he falls off into solution and his electrons get going. And the electrons go through here. You see the voltmeter. That's one of the things that's definitely different about a voltaic cell. And then they come through here. They go right through into the copper. The 2 electrons hit this copper ion and make it copper metal. And then the copper metal latches on to the electrode. So the electrons flow straight through into the copper ions, forming copper metal. The copper metal starts making big on the copper solid electrode. The salt bridge has ions flowing this way and this way, and we'll get it, the demonstration gets a little bit into specifics of what those actually are, and it has to do with what the other ion is in solution and how they neutralize each other. So 2 things that voltaic cells have that are a big clue is there is a voltmeter or a resistor of some sort, and there is a salt bridge. Those are 2 things that are not present in the electrolytic cell, which we're going to find out in the next video. And we are done.